So think back before Christmas, we skipped chapter 6 because that's something that I taught in science when it came to capacities and conversions from standard to metric and different changes in the metric system. So we should know how to do those. And then we skipped chapter 7, 8, and 9 to get into geometry. And in geometry, we looked at all sorts of different aspects of that, which we will get back to once we get through these chapters that we skipped. So we're going all the way back to chapter 7. And in chapter 7, we're introduced to exponents. Now, exponents is not something brand new to us because I've mentioned it several different times, and I've also gave you some examples on other videos of exponents. Most recently, we talked about squared and cubed exponents with our labels on area and volume. When I multiplied two things together, so it was squared. When I multiplied three things together for volume, it was cubed. But I can't have exponents such as this 9. So when it comes to talking about exponent numbers, I need to understand that there are two parts, and that's where the book begins to explain it to us. Then when we have an exponent is a number that tells how many times a number called the base is used as a repeated factor. So when we zoom in on that definition from our book, then it gives us an example. So our base, a repeated factor. So a factor is a number in a multiplication problem. So I know that I have a 5, and however many times that base is repeated, or that repeated factor, the number of times it's repeated is called the exponent. It's also called the power, depending on where it's being used. Most of the time in science we've talked about it as a power, but I've seen it on the I-step and in different math books also where it refers to the power. So just understand if it says it's to the power of this, it's saying that what the exponent is. So when I look at this, it's saying that if I have 5 times 5 times 5, then if I don't want the value, but I just want it shortened as a math problem, I can do the same thing as 5 to the power of 3. It's going to be really important in chapter 7 and moving forward because we're going to be doing a lot of exponents and building on this idea, doing it in an algebraic equation. And once again, an algebraic equation is very easy. It just means that they've added letters to these multi-step math problems. So don't let that get confusing for you. When I work through this, then, make sure that if it says power or exponent, you know it's the small number. The base or the repeated factor is the big number because it could be interchangeable. So let's look at the first scenario they set up for us as they introduce exponents. Talk about a video game, and we have 4 different levels that we can get to, A, B, C, and D. And then here they show us our bonuses that we can receive from the game if we get to level D. And what it wants is, well, it wants you to use an exponent to write this level of bonuses with an exponent. So then remembering that as we go through this, it talks about where it is, we're getting to level D, we're playing a video game, we're talking about the bonuses that it gives. So we've got to focus on what we're writing. And then all of these are always set up with our thinking pattern, our thinking path. This is what we should have in our mind as we work through these until we really have a solid base and foundation to be successful with them. So it walks us through and we fill in the blanks. The number blank is used as a repeated factor. So once again, the repeated factor is the number that's shown over and over and over again in the multiplication problem. When it comes to an exponent number, we call it the base. So we're going to write in our books, right? Because it's important that we follow along on these videos. Here's the problem that we had when it came to circles. I made the videos. I walked through the practice pages with you. Yes, there were a couple of them that I didn't read the question correctly, had a mistake in it, but that does happen. But some of you thought after 2 practice problems you understood everything when it came to circles. And then when you got your assignment back after I graded it, you didn't do well. Well, when you look at your practice pages and you only solved 1 or 2 things and you thought you had it, you didn't. That's why I always work through several practice problems for you to do. That's why these are also available for you to look at from home. Granted, you may not have Canvas from home, but I've told you they are on my webpage for the school website, and you can get to them. And maybe mom and dad want to help you. Mom and dad have been told through emails and my newsletters that they're more than welcome to go and watch these videos as well. So maybe they had forgotten how we do some of these math problems. The only really difficult assignment when we had circles was finding the surface area and the volume of a cylinder. And I agree that was difficult. That's why I worked through several practice problems with you. Every other assignment other than that should have been a solid A for everyone. But I didn't have that. because you didn't want to take the time to do as you know I would expect you to do. Please follow along in your book. Please fill in the blanks and make sure you're paying attention as we're doing it. It's important. It really is. It's for your benefit. The number blank is usually your repeated factor then would be the 3. That is going to be my base or my repeated factor. It's the only big number that's up there. 3 is used as a factor how many times then? Then I count them 1, 2, 3, 4. So I know it's to the 4th power, or there are 4 times. So then I write the base and the exponent. So I have my base, which is my large number, my exponent, my power, or if you're typing it in, you go under your fonts and you highlight the number that you want to make your exponent, and you have to choose what is called superscript. You'll also see in your font bar at the top of your computer where your fonts are, one of them has a subscript, which we use in science like H2O, and then it also shows an X with one up above, and that's your superscript. So a player can receive blank bonuses in the level. Well, then how do I solve that? Well, to solve that, then I pick up my handy dandy calculator. And once again, what I need to see is the math problem written down that you're going to solve. And then once I have the math problem that you're going to solve, then we write down our answer. So in my handy dandy calculator, I would type in 3 times 3 times 3 times 3 equals, and I'm going to get an answer. To show my steps, like in February, next month, on the I-STEP test, which is a written book, I've got to show these steps and how I'm doing my math. And this is not difficult, I promise. It's just taking the time to do it correctly. They give you enough time to do well on it. Some of you will rush through and then want to sit there for 15 or 20 minutes. Go in and show your little steps that you did so you can get all of the points possible and be successful. When I do these, I always do basically an upside down caret. Usually a caret points up. These carets point down mathematically, and it shows me the math that I'm doing, and then I connect it to the next one. So I take my first 2 factors, 3 times 3 is 9, and then I do another one. It's a little slanted, but I'm going to connect it to my next 3. So then I'd have 9 times 3, and 9 times 3 is 27. And then I'm going to connect it again to my last one, and show that 27 times 3 is 81. So I have my math problem. I showed my really simple steps here that I had to do, and I got my answer of 81, and I've been successful. Well, let's look at these practice problems. Use one or more exponents to write the expression. So once again, we have expressions and we have equations. Expressions are math problems without equal signs and an answer. An equation is a math problem with an equal sign. Those are going to be important because we're going to start doing expressions here in just a couple of lessons using all sorts of multi-step, the order of operation, and things like that. So right now, I'm not even asked to solve for these problems. It says the number blank is used as my repeated factor, my base, my one that's there. So I have 1, 2, 3, 4, 5. 5 different times I've written the number of 7. So I'm going to write a 7 there on my line. 7 is used as a factor how many times? Well, we said 5, so I put my 5 there. So my expression is a math problem. We don't necessarily always think about numbers with exponents as being an expression, but mathematically it is. It's the whole number, the base, multiplied by itself that many times. 5 times, or 7, 5 times. When I go to the next one, I see that I actually have 2 bases, don't I? I have 6s and I have 8s. So I know that I'm going to show my expression, and it's going to be multiplication, because numbers with exponents are always multiplication, unless they would indicate here that I was adding between the 6s and the 8s. This is straightforward multiplication, so I know everything is going to be multiplication. The numbers of 6 and 8 are going to be my repeated factors or my bases that I'm going to use, and then I look at how many times I have 6 written down. 6 is written down 2 different times, and my 8 is written down 3 different times. So as I'm doing it, I know that I'm going to write my expression. Once again, a math problem without an answer and an equal sign. 6, how many times is its exponent? To the 2nd power, or we could say squared. And 3, or cubed, for my 8. So this math problem, 6 times 6 times 8 times 8 times 8, is written as 6 squared times 8 cubed, or 6 to the 2nd power times 8 to the third power. Once again, I haven't been asked to solve for them. It doesn't ask what the answer is or the value is equal to. So all I'm looking for right now is figuring out how to write the exponents and the expressions that they create. Now on example 1, then it says to find the value. So I'm going to have to do everything that it's requiring me to do. First it says to use a repeated multiplication to write 10 to the third power, or 10 cubed. So I'm going to take the repeated factor, which is 10, and I'm going to write that factor how many times? Cubed is 3 times, so I'm going to write it out. 10 cubed is the same as 10 times 10 times 10. Now in the same way that I worked before, using my caret, I'm going to do this one also. 10 times 10, well I type it in my calculator, 10 times 10 equals, and I get 100. Times 10 equals, and I get 1,000. So 10 cubed, 10 to the third power, is the same thing as 1,000. I can check that real quick by quickly typing in 10 times 10 times 10 equals, and I'm still going to get 1,000. And I've checked my work, and then I know I'm going to get a good grade. So let's look at this one. I'm going to do a tangent here once we work through it and give you some information that deals with some scientific notation, which sounds like big scary things, but a couple of you are going to be seeing that on Moby Max within the next week or two, and it's not difficult as long as you think about what it's asking. This one says that I have 7 to the first power. The repeated factor, the number that's the base, is just a 7, correct? So then what's the repeated number? Well, I write that factor how many times? I only have to write it once, right? So 7 to the first power is just the same as saying 7. So what I want to do a tangent on is the idea that any number at all that we would write to an exponent of 1 is just that number by itself. In the same way, I can apply the idea of having an exponent of 0. You're going to see that definitely in 7th grade, 8th grade, 9th grade, when you get into scientific notations and some higher math and chemistry. Any number with an exponent of 0 is just 0 itself. So if I'm doing scientific notation, it may say that I have a number like 307. But if I have 307, 307, there's nothing in the tens place. So there are times that you're going to see 10 to the 0 power. So what they're telling you is when I write out 307 with exponents in scientific notation form, then in the tens place there's nothing there. They don't just put a 0. Right? So when it says in scientific notation that everything has to be written as exponents, you're going to see a place value sometimes with a 0 up there. And just remember, any number, even if it's a trillion to a power of 0, it's actually just 0. Alright, so moving on. Looking at the directions, write 81 with an exponent by using 3 as the base. Okay, so this is a guessing game. I don't really like guessing games. I like doing things systematically and through mathematical steps, but this does work. For me, it just takes longer. We're going to be looking at a couple things here in the next couple of videos where it really is a guessing game on where to put parentheses to get to a number that is they're expecting you to find. And so I'll talk about that again when I get to that video. But if I want to just guess as to how many times I multiply 3 by itself, then we can set it up, and they're setting it up for you as, well, I would start with 3 squared, or 3 to the second power. And I do 3 times 3, and we know that 3 times 3 is 9. And then I would do 3 to the third power, and I would get 3 times 3 times 3, and 3 times 3 is 9 again, times 3 is 27. Well, then I would do 3 to the fourth power, and I'd have 3 times 3 times 3 times 3. And then I would do 3 times 3 is 9, and 9 times 3 is 27, and 27 times 3 is indeed 81. When they tell me what my base number is going to be, and they give me a number, and they tell me that they're going to write it with an exponent, I like to think of prime factorization. Now, we haven't looked at a lot of prime factorization in the past 2 months, right before Christmas break, but we did it a lot for the first 2 months of school at the very beginning. When we did it, the majority of you in here preferred to do the steps. So I'm going to do the stairway steps with the prime factorization and then I'll remind you what the tree looked like, which is what I have normally done. But if I know that I have the number of 81, and I know that my exponent is going to be written with a base of 3, then I'm going to just divide by 3 until I'm left with nothing but 3's. So my prime factorization 3 goes into 81. Well, 3 goes into 81 27 times. And then I'm going to continue to divide until I get all 3's. So 3 will go into 27. 3 goes into 27 9 times. And 3 goes into 9 3 times. So I ended up with all 3's, which was my goal, because that's what they told me I was going to write it with. Well, then I count how many are there. And if you remember, we always circled our prime factorizations when we were doing those earlier this year. When I see that I circled it 4 different times, then I know that I have a base of 3 and an exponent of 4. Now, prime factorization with a tree just basically goes in the opposite direction instead of up the stair step. So you would have written 81 at the top and treed it, and starting with 3, and 3 would go into 81 27 times. And then you would tree the 27, and 3 would go into 27 9 times. And then you would tree the 9 and end up with 3 3, and then you would circle your 4 3's again. Still get you to the same point. So we get the same answer that we would have gotten by doing the guessing game of how many times we're going to write the 3 and find its exponent. Now this question, I know I've heard it last week before, or right after Christmas break, and I heard it all before Christmas break, but I don't like to use words. Well, you guys don't get a choice. Number one, the book says these are the directions and you're to explain, which is writing words. Number two, your I-STEP test is next month, and the first I-STEP that you do is a written book. And there's 4 or 5 math problems that you have to solve and explain how you get your answer. From now on, from 6th grade on, all the way through high school, through trade school, through J. Everett Light if you go there, and through college, you have to write and be able to explain in mathematics. It's just part of math. When you get jobs, if you have to do any kind of reasoning or explaining, you're going to have to write reports and write down the information as to why you did the steps that you did. This is just part of life. So get used to writing. You'll be okay, I promise. Explain how to write repeated multiplication of a factor by using an exponent. So how do I write repeated multiplication using a factor? A factor is just a number used in a multiplication problem. Then using it in an exponent. So here's your answer that you would write down. And I will expect all of you to write down. I'm going to read through it twice, and then you can pause the video and continue on once you have it written down. So the repeated number, it is written as the base. And as that base number, then you're going to write the number of times it's repeated as the exponent. So we had 3 times 3 times 3 times 3 a moment ago. So I wrote the base number, and then I wrote the exponent as the number of times that I used it. So it was 3 to the 4th power. So the repeated number is written as the base number, and then you write the number of times it's repeated as the exponent. So pause the video now. Make sure you have it written down. Then unpause it. We'll continue on to the practice problems. The next practice problem is this one here. It says, is, asking a question, 5 squared, or 5 to the 2nd power, equal to 2 to the 5th power? Now, when I give people assignments on exponents, every year I see the same thing. Some people don't stop, pause, and think for a moment, and they just jump right in there. And they know there's multiplication involved. And they say, okay, 5 times 2 is 10. 2 times 5 is 10. They're the same thing, and then they move on. That's not how exponents use. They are telling me multiplication problems, but this is a superscript for a reason. I have to say, no, they aren't the same. Because when I write them out, and this is where some of your math steps can be included in your written explanation where I use words. 5 squared would be 5 times 5 equals 25. So I can use numbers there. And 2 to the 5th power would be 2 times 2 times 2 times 2 times 2. And when I do my handy dandy calculator and I hit equals, that gives me 52. They are not the same. So use words, show some of your math, but make sure you are explaining to the reader why they're not the same thing. You may see on the I-STEP test a problem worked out, and you have to figure out why their answer is wrong. And it may be that an exponent question where they had 5 to the 7th power, and they said it was 35, and then they continue to work out the steps. So you have to be able to spot those type of things and be able to explain why that's wrong. Because they had to write 5 times 5 times 5, 7 times. So now we have several problems to look at. First, write 2 to the 4th power by using repeated multiplication. Then find the value of 2 to the 4th power. So I have to write it, and then I have to solve it. And they start it for me. I know I have 2 to the 4th power. They give me 2 times 2. Well, I only have a 2, so I'm going to put 2 more, right? So I go 2 and 2. And then I'm going to have to do 2 times 2 times 2 times 2, 4 different times. My hand and the calculator. 2 times 2 is 4. Times 2 is 8. Times 2 is 16. I check it on my handy-dandy calculator. It is 16. So I have written it as the repeated multiplication problem, and I have found its value. Use one or more exponents to write the expression. So here I'm not asked to solve for these, but I'm curious type person, so I solve for them just to show you what the answers would be. So my base is going to be what? Well, I have one of them, right? So my base is 7, and how many times is it written down? 1, 2, 3, 4. So I have an exponent of 4. So if I pick up my handy-dandy calculator, if you want to do it with me, and you type in 7 times, 7 times, 7 times, 7 equals, you're going to get this answer. 2,401. Not the same thing as 28, is it? So it's not 7 times 4, it's 7 to the 4th power, so I have to multiply 7 by itself 4 times. When I look at question 3, I have only 5, so I know my base is going to be a 5, and my exponent is going to be 1, 2, 3, 4, 5. So I have 5 to the 5th power. Well, 5 times 5 is 25, so I know that that's not going to be my answer, correct? So if you type it in your calculator and you get 25, understand that can't be the right answer because it's not direct multiplication. It's typing it in on your handy-dandy calculator. Ready? 5 times, 5 times, 5 times, 5 times, 5 equals, and you should get 3,125. That's a much bigger number than just 25. So I've got to make sure that I have my brain in check and I stop to think for a moment before I do my math, and then I know that that is writing this out 5 times as a multiplication problem, and then hitting my equal sign. Notice on number 4 it's a little different. It's like that 6 and 8 earlier. There are 2 different numbers. So I know I'm going to have a 3 and I know I'm going to have a 4. It's all multiplication, so I'm going to have 3 times 4, but they're each going to have 2 as my exponents. So they're both going to be squared. So I'm going to have 3 squared times 4 squared, also said as 3 to the 2nd power times 4 to the 2nd power. So if I was solving these, and once again the book doesn't tell you to, but I wanted to, then I would take 3 times 3, and then I want to take 4 times 4, and my last step is to multiply those together. 3 times 3 is 9, and 4 times 4 is 16, and then when I type those into my handy-dandy calculator, 9 times 16, I'm going to get 144 as my final answer. These do not have to be written down, but as I said, I'm curious and I want to know what the answers were going to be. When I look at these then it says to find the value. And if I don't show the math problem that I'm using to find the value, I'm going to have to redo it the next day when I get it back because they're going to be circled as incomplete. So make sure you write down the math problem that you're doing for me, other than one of them, which is always an obvious answer. On 5, I have to write down the math problem of 20 times 20. The base, or the repeated factor, is 20, and an exponent of 2 tells me to write it 2 times. And then I can do 20 times 20 on my handy-dandy calculator, and that is 400. On number 6, I don't have any math that I have to do, because I've told you earlier on the video that any number to an exponent of 1 is just that number. So I'm going to put 82. If it was 82 to the power of 0, then you would just have to write what? Hopefully you thought 0, because that's what I told you a couple minutes ago. So on number 7, write down your math problem that you need to have written to show your work. So hopefully you wrote down 3 times 3 times 3 times 3 times 3. You wrote it 5 times because that's what the exponent tells you to do with that base number. Then you can type it into your calculator, 3 times 3 times 3 times 3 times 3, and you will get 243 as your value. For number 8, for number 9, for number 10, for number 11, well actually not number 10, but these are all going to be using your prime factorization, your stair step, to figure out what my exponent's going to be. Write 32 as a number with an exponent by using 2 as the base. So they tell me I'm only going to have one number there as my base. So I'm going to take my 32, after I write my base down, I'm going to divide by 2 until I only have 2's left. So 2 goes into 32 16 times, divide by 2 again. 2 goes into 16 8 times, divide by 2 again. 2 goes into 8 4 times, divide by 2 again. Once again, I'm going to go until I'm done and I don't have any 2's left. 2 goes into 4 2 times. Now I'm done. Every one of my 2's have to be circled, so I know that's my exponent. There are 1, 2, 3, 4, 5 of them, so I know I'm going to have 2 to the 5th power. On number 9, I know I'm going to have only one number, so it's a prime factorization question. I'm going to take 125 and see how many 5's go into it. So I set it up. 125 divided by my base of 5. 5 goes into 125 25 times. Divide by 5 again. 25 divided by 5 is 5. I have all my 5's left as my answers, so I circle them. There were 3 of them, so I know that 5 to the 3rd power, or 5 cubed, is the same as 125. This one, I don't have any math that I have to do at all, do I? Because I have the number, it has an exponent, and it's equal to the original base number. So I know that exponent has to be 1. My last one, number 11 over here, shows me 900, and that the base is going to be 30. So I do my prime factorization. I'm going to take 900 divided by 30. And I set it up, 900 divided by 30. 30 goes into 900, handy dandy calculator. 900 divided by 30 equals, well, it's 30. So I know that my 30 is going to have an exponent of what? Hopefully you have 2. Because there are 2 30's that make it up. So 30 to the exponent of 2, or 30 squared, is 900. Now we're going to look at number 12. Sometimes we don't do these, but especially on the introduction video, we do, because a lot of these are the type of questions you get on the backside, 1 through 6. So it says to use repeated reasoning, so your repeated factors and thinking about what and how it applies. Find the values. Find the values of what? Find the values of each of these 4's to these powers, or these exponents. So I'm going to work through those. 4 to the 1st power, well, any number with an exponent of 1 is just that number. So 4 to the 4th power, or 4 to the 1st power is just 4. 4 squared, or 4 to the 2nd power, 4 times 4 is 16. 4 cubed, 4 to the 3rd power is 4 times 4 times 4, which is 64. 4 to the 4th power, 4 times 4 times 4 times 4 is 256. Once again, I'm not doing that in my head. I wrote down the math problem that I was doing, picked up my handy dandy calculator, and I typed it in. 4 times 4 times 4 times 4 times 4, there's 5 of them, because it says to also find 4 to the 5th power. 1024. Once again, if I don't show my work, I'm going to have it circled and given back to me, and when I have to do it the next day anyway, on top of the next day's assignments. So please show your work the first day. Then I look at my next step in this question. Look for a pattern. Well, a pattern. The only pattern that I really see is if I look at my 1's position, I have a pattern of 4, 6, 4, 6, 4. So I do have a pattern. Well, it says to use that to predict the 1's digit in the value of 4 to the 6th. It didn't ask me to solve for 4 to the 6th power. It asked me to use my pattern and my reasoning as to what the ones digit's going to be. So if my pattern is 4, 6, 4, 6, 4, what's my next number going to be? Hopefully you thought to yourself that if I predicted my next step in my pattern, that the pattern being 4, 6, 4, 6, 4, that we would predict that it is going to be a 6. And it would be if you solve for it. On number 13 then, it says, select the expressions that are equivalent to 32, mark all that apply. So once again, if you just jump in there and you start without thinking and pausing and think about what exponents tell me, I may think, well, 2 times 5 is 10. No. 8 times 4 is 32. Yes. And then I have to solve for each of these so I know a yes or a no. So if I'm going to mark all that apply, well, 2 to the 5th power would look like what? 2 times 2 times 2 times 2 times 2. 5 times, right? And when I do that, and then I type it into my handy-dandy calculator, and hit equals, I end up with 32. 8 to the 4th power, what does that look like? 8 times 8 times 8 times 8. 4 times. That gives me 4,096. That's not a possible answer. 2 to the 3rd power times 4. So 2 times 2 times 2 times 4. So when I work that out, 2 times 2 is 4 times 2 is 8. 8 times 4 is indeed 32. And 2 times 4 is 8 times 4. Kind of looks like what that did is 32 as well. So I have one of them that is not going to be marked, but I have 3, A, B, and D, which are all the answer of 32. Actually, I got those backwards, didn't I? I apologize. It should be A and C and D marked with check marks, and B should have an X on it because that's not right. I apologize. So before I let you go on this video to do the homework, I want to give you a reminder of what we did before Christmas break in science. Think back to science because these are going to be on your homework. Remember that King Hector doesn't usually drink chocolate milk, and that the king is always to the top left, and all of its subjects is over to the bottom right. And then if I'm leaving the king and going down certain steps, then I'm going to move my decimal to the right however many steps I take. If I come from the bottom up to the king, then I'm going to be humble. I'm going to move my decimal to the left. It makes me smaller. The king makes me feel important. He makes me feel good about myself. As I'm leaving, I become bigger. I have a bigger self-esteem. Coming up to the king, I'm a little nervous. And so I become humble and I become smaller. Up to the king, I move to the left however many times I need to. Down from the king, I move my decimal to the right how many steps I need to. You'll need to remember that for your homework on tonight's lesson. So exponents, our introduction to chapter 7, lesson 1, is just remembering what an exponent is, how it works, and be able to solve for it. That I have a base, which is my repeated factor, the big number, and how many times I write it down. My exponent, or my power, tells me how many times to write it down as a multiplication problem. So if this was 13 to the 9th power, I would have to write the number of 13 times itself, times 13 times 13 times 13, 9 times. So stop and pause and think before you write down the math problem. Make sure that you write down the problem, that I can see it. Then you use your calculator to do all these multiple steps here and make it easier on you, and make sure you have your answer on the answer line so that I can give you credit. If you have any questions as you're working through it, please come and ask.